In this video, in our Get Started series, we'll begin building our first model. Over the course of the series, we'll construct a simple cooling water circuit, complete with pumps, valves, and heat exchangers. In this first step, we'll look at the main distribution header, which supplies cooling water to 5 sub-circuits. We'll begin by opening a new flow sheet and placing some system boundaries. For this model, we'll use a known flow node at the inlet, simulate the discharge from the pump, and we'll use known pressure nodes to simulate the exit conditions at 5 locations. To place boundaries or any component, we simply select them from the component palette and drop them onto the flow sheet with a single click. Now that the boundaries are in place, we can connect them with pipe elements. Simply select a pipe from the palette and start the run with a single click. Move the cursor to the pipe endpoint and click again to place the element. You can see that FluidFlow automatically places a component, in this case an open pipe, at the end of the run. As we continue to connect pipes, FluidFlow will add the correct components to the model as appropriate. In this way, models can be built quickly and effectively without having to worry about placing T's and elbows on the flow sheet. Now that the connectivity is defined, we can define some of the inputs in our models. We do that from here in the Input Editor. The fields in the Input Editor are reflective of the type of component selected. So for this known flow, we can set properties relevant to the node. We can define the flow into the network and set at or edit our design flow of 50 meters cubed per hour and a temperature of 25 degrees Celsius. We can also select the fluid from our extensive database, as you can see here, and use a search window to help us navigate it. Next, let's look at the pipes. I'm going to multi-select all the pipes in the main header by holding the Shift key and clicking on each component. Then we can set the common properties for all the selected components for the Input Editor. Let's set the length of each pipe to 30 meters. I'll not worry about pipe size just now because we'll look at that in more detail later. Here we can also specify the friction loss model. And we can use either Moody or Hazen-Williams, or you can directly enter the Darcy friction factor. You can also select the surface roughness from our database, or again, enter your value directly. Now, let's set the length of each leg to 15 meters. We can also show some properties in the flow sheet. Let's select the pressure boundaries and display the flow result on the flow sheet. This will allow us to quickly see the flow distribution through the network. We can display the results at the top, bottom, left, or right of the component. Now let's look at the directional components. Directional components are denoted by a colored dot, usually red, which signifies that a flow direction needs to be specified before calculation. The T-junctions in this model are examples, and the description can usually be found from the Input Editor, like this one for converging or diverging T's. We can set the location of the dot by selecting the component and clicking on the 3-dot button to cycle through the pipes. We can also look at the different loss models we can use for T's and select the preferred option. Finally, before we calculate, let's save our model. We can do that by clicking on the Save As button and navigating to our preferred save location. Give the model a name and click Save. Now we can press Calculate and we get a notification at the bottom of the screen telling us the calculation is complete. We can see the flow directional arrows are now in place and the results are visible on the flow sheet. We can also see some red markers which indicate a warning or error of some kind. We'll look at the results and messages in the next video, interrogating your results.